The remainder theorem states that given a polynomial f of x of the standard form, then when f of x is divided by f of x is divided by x minus p, where p is a real number, then we will get a remainder which is f of p. So when we divide f of x by x minus p, the remainder is f of p, which means if we substitute the value of p for x in this expression, whatever value we get, that is the remainder. Let's see a bit more of this. Let's take a normal division that we do. Let's divide a number 14 by 3 and see what happens. We get 3 4s are 12, so the remainder is going to be 2. So we can write 14 as 3 times 4 plus 2 now. So 3 times 4, the quotient multiplied by the divisor, plus the remainder. This is the form in which we can write 14 as. Now let's try and apply the same thing to the polynomial. Let's take a polynomial x square minus x plus 1 and let's divide it by, let's say, x minus p form, x minus 2. So when we do this, x times x is x square, minus 2 times x is minus 2x, and now we subtract, x square goes off, minus x plus 2x is x, and we bring the plus 1 down here. Again, x times plus 1 gives x here, minus 2 times x is minus 2 times 1 is minus 2. So then when we subtract, again x goes off, 1 minus of minus 2 is 1 plus 2, which is 3. So we get a remainder, let's call it r, equals 3. And let's try and express it in the same form that we saw here for the number 14. X minus 2, which is this, multiplied by the quotient, which is x plus 1, plus the remainder 3. This is equal to our polynomial f of x, which is x square minus x plus 1. Now in such a case, when the remainder theorem states that the remainder should be f of p. That means if we substitute the value of p for this f of x, we should get the remainder 3. Let's try that. So the value of p here is 2. X minus p, then p is the positive value of 2. When we substitute here, we get 2 square minus 2 plus 1. So 2 square is 4, 4 minus 2 is 2, plus 1 is 3. So we get to prove the remainder theorem through this example. And we can also see it very clearly here. When we express the polynomial in this form, if we substitute 2 in the place of x, this entire thing goes off as 0 and we get only 3 as the remainder there. So that's another way to look at it.